Well, yeah, I really want you to, because I'm going to give you about a week to do it, all right? And any questions you have, you can definitely come and talk to me. Get this damn thing on, all right? You can definitely come talk to me, and we can work through it, all right? I mean, the only thing I don't want you to do is I don't want you to work in groups on it, all right? But any question you have, come to me, and we can work through it, okay? And really, I hope you do that for everything we do, all right? Okay, so we ended on Monday talking about the different parts of the periodic table. Okay? We said so far that the periodic table tells us, first off, how many electrons we have, because those electrons are going to undergo chemical reactions. Okay? But more importantly, it's these electrons that are on the outside. I didn't draw a picture of that. Okay? Yeah, where'd that go? Apparently that picture disappeared. Okay? But it's those electrons on the outside, those valence electrons, that are going to undergo the chemical reactions. Okay? So if I start with hydrogen, hydrogen only has one electron. Helium has two. All right? But that first orbit can only fit 2 electrons. So that now when I need that third electron for lithium, I need to add another orbit. Okay? And I keep going until I get to neon, and that second orbit can only fit 8. So if I need to add another one, I have to go back to sodium. Okay? So I keep adding orbits to accommodate these new electrons. And so that's what I mean when I say everything in group 1A has 1 valence electron. Everything in this third period has 3 orbits. Okay? They have a different number of electrons in those orbits, but everything in group 3, in the third period, has 3 orbits. Okay? Now, the other thing the periodic table is telling us, which we haven't talked about yet, is that everything to the left of this line here is a metal, and everything to the right is a nonmetal. Okay? And so really, I mean, when I ask you that on the test, okay, that should be really easy, because it's just saying right here, everything to the left is metal, everything to the right is a nonmetal. Now, this periodic table makes it a little bit more difficult. Okay, can you see this kind of faint orange line here? Okay, that's the same line there. Okay, and everything to the left is a metal, and everything to the right is a nonmetal. And really, I think we probably already know some basic properties of metals and nonmetals, right? Can someone tell me what's something most metals have in common? Okay, they're solid. Okay, and if we look on the periodic table, pretty much everything to the left of this line is a solid, except for, well, mercury is a liquid. Okay, well, helium's over here. That's hydrogen. Hydrogen's weird. Okay, we'll talk more about hydrogen later. And remember, these rules are just hold true for most things. Okay, so most of these metals here are solids. What else can we say about most metals? What? Well, yeah. They conduct electricity. That's something we can say a little bit more broadly. They conduct electricity. What else do they conduct? Heat. Okay. Yeah, that's true of pretty much everything, though. They'll expand when heated and contract when cooled. What if, I don't know, I took a copper wire and took a hammer to it? Yeah, that's what I was looking for. Malleable. And really, that's just a fancy way of saying that I can form it into shapes. Okay, what goes along with malleable? Heard ductile? Yeah, and that just means I can pull it into wires. Okay, yeah. So if I had a piece of copper wire in here, I can take a hammer, I can flatten it out. Okay. At the same time, if it was a thin enough piece of wire and I was strong enough, I could pull that into an even thinner wire. What?
You talking about pulling it apart?
Yeah. Well, I could pull it apart, or I could, if I was careful, I could probably stretch it a little bit first, right? And that's what we mean by malleable and ductile. It means I can form it. I can pull it into wires. Now, nonmetals, on the other hand, we can kind of think of being as the opposite. Okay? So they're not all solids. If we look at the periodic table here, okay, carbon, phosphorus, silicon are solids, okay, but nitrogen, oxygen, fluorine, neon are all gases, okay, and bromine's even a liquid. So nonmetals we can say come in solids, liquids, and gases. What's the opposite of conductor? Insulator. Okay? So we can say for the most part, most nonmetals don't conduct heat and electricity very well. They're used as insulators. Okay? And what about malleable and ductile? Remember we talked about pencil lead this last time? Remember pencil lead is just carbon, right? Which is a nonmetal. Okay? So what would happen if you took your pencil lead out of your pencil, took a hammer to it, and tried to flatten it into a sheet? Yeah. It just turned to dust, right? And that's true of most nonmetals, all right? We say they're not malleable, they're not ductile, they're brittle. Okay? They'll break. I mean, we can even think about that simpler, all right? Well, maybe not simpler. Okay? If I had a metal bowl here and I dropped it, okay, what's going to happen to that metal bowl? Nothing. It's going to make a loud sound, right? But what if I had something like a ceramic bowl? It just shatter, right? Okay? Ceramic bowl is made of mostly nonmetals there. Okay? So that it is brittle, it'll just break. Good. Okay? And so really this is just something else we can add to what the periodic table tells us.
What about like rubber?
Well, rubber, like I said, yeah, rubber is a combination of really, for the most part, carbon, oxygen, hydrogen, and things. And so when you start combining different atoms, then you get different properties. And like I said, these are only generalities, okay? So in general, if I have a pure nonmetal, it's going to be brittle. If I have a pure metal, it's going to be malleable, all right? It's not always true, but they hold true most of the time. But this means, too, that if I do ask you next time on the next test to tell me maybe not 4 things about phosphorus, but 10 things, okay? Well, you can say that, well, it's a nonmetal. It's to this side. So that means it's probably an insulator, and it's probably brittle, okay? Now, we have this line here dividing it, and things along the line can get a little bit iffy, all right? Just like we said, silicon here, silicon, germanium, arsenic. You know where these 3 things are used?
Silicon can be used in the batteries.
Yeah, it's used as in like caulk and stuff like that as an insulator, and it's also used in electronics. Okay, so when you're talking about using it as, what would you even call that? Whatever. When you're using it, you're talking about filling in grout or whatever. All right, you're talking about its insulation properties. But when you use it as a computer, all right, you think about it conducting electricity. So it's that ability to switch on and off, whether it's a conductor or whether it's an insulator. Okay, so things along the line are a little bit iffy. All right, good. So let's go back to this periodic table then and look at something else and see if we can say 10 things about it. Okay. What about barium? Okay, we never do anything with barium, right? What can you tell me about barium? Okay, it has 6 orbitals, 2 valence electrons, 56 protons, 56 electrons. Atomic mass is 137. It's not a transition metal. It is a metal, though. Okay, just remember all these blue guys are transition metals that we're not going to spend much time on. Okay, it's in group 2A. It's in the 6th period. If it's a metal, then It's probably a good conductor of heat and electricity.
How valuable?
It's probably malleable. It's probably ductile.
Wait, how do you know it was metal?
Because it's to the left of this line.
Oh,
Okay, so really, these are the only nonmetals. Everything over here is a metal. Okay, even all the way over here.
what does the group down at the bottom fall under the metal?
It's a metal because actually it fits right here. Okay.
What's a transition metal? I think I missed that.
Well, we're going to focus on representative elements, and we did just briefly talk about this. Okay. So the rules we've talked about so far hold true for these representative elements here. Okay. But things aren't so true when we talk about the transitions. Like we can tell real easily that carbon, since it's in group 4A, has 4 valence electrons. Okay? But it gets more complex here. We can't tell just by looking at how many orbitals manganese has, or how many valence electrons even iron has. Okay? Things just get a little bit more complex there, so we'll start with the representative ones. All right? Good. So, now that we know basically how to read the periodic table, know metals and nonmetals, the last thing really in this chapter we need to talk about is how we, if I can find it, how we name molecules that result from 2 or more atoms coming together. Okay? And really this isn't too bad. Okay? First off, all right, if I have something like a metal with a nonmetal, naming is pretty easy. Okay? Because if I think about something like NaCl, anyone know what NaCl is? Which is also salt. Okay? Lots of things already have names, all right? Like NaCl is salt, okay? H2O is water, okay? But really, every single molecule that exists, we can give a chemical name to. Yeah. So a chemical name just takes what the individual pieces are and puts them together. So for NaCl, we just start with the metal here, sodium. And since we have chlorine over here, we have chlorine. And the only difference, we don't call it sodium chlorine, we just change this INE at the end of the nonmetal with an IDE. So sodium chlorine together to form a molecule is sodium chloride. That's it. There we go. Fe2O3, that's just rust, but its chemical name is iron oxide. It doesn't matter that we have 2 iron atoms and 3 oxygen atoms. It doesn't matter that iron is one of these transition metals. It's still a metal. So we have a metal with a nonmetal, so it's iron oxide. Okay? Well, these rules hold true for metals and nonmetals. Okay? So any metal and nonmetal we have, right? Even if it's something like, I don't know, Li3N. What would I call that? Lithium nitride, that's it. Nope. Because as long as we have a metal and a nonmetal, we don't care how many there are. Okay, there could be 10 lithiums or 100 nitrogens. It's still lithium nitride. Okay? So metals and nonmetals are easy. Yeah.
What about nitrate, lithium nitrate?
Well,
I wouldn't say it.
no. Because when we talk about this, all right, we're talking about one metal bonding with a nonmetal. Okay? We can definitely get more complex with this, okay? Because we could have 3 lithiums, 1 nitrogen, 2 carbons, and 1 oxygen. All right. But these rules hold true when I just have one type of metal with one type of nonmetal. All right. No matter what it is, all right, we just add that IDE to the end. Okay. Now, things do get a little bit more complex when I start naming 2 or more nonmetals. Okay.
What about hydrogen 2 sulfide, the influence flame?
You guys are asking all sorts of good questions. No. So was that?
Hydrogen 2 sulfide, H2S.
Okay. Hydrogen sometimes acts like a metal and sometimes like a nonmetal. Okay. So we don't really have a great way to name this. Okay. In this case, what we'd actually call this is we call it hydrogen sulfide, because in this case hydrogen acts like a metal. So we have a metal, all right, with a nonmetal. But at the same time, all right, you might also see it dihydrogen monosulfide. Okay? Because when we have 2 nonmetals coming together, we have to say how many of each atom we have. Okay? So let's start with something that's a little bit easier than this. Let's just get rid of this. Let's start with something a little bit easier. Okay? Let's say we have 3 carbons and 4 oxygens. Okay? You guys have taken chemistry before. So here we have to say how many of each we have. But we still start the same way. We still have carbon and we still have oxygen. Okay? So just like before, I'm going to take off this end part and put an IDE. Okay? But in order to say how many of each I have to use a prefix. So here, 3 carbons, tri, and then 4, it's going to be tetra. So now this is the only bad thing. We do have to memorize this. Okay? So we do have to memorize what these prefixes are. And this is definitely in your book too, all right? So you don't have to worry about copying this down right now. Okay? But 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, okay, 6 is hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Now, a lot of these are not too bad to remember. Okay, mono, di, and tri. Tetra's a little bit weird, but someone in one of my previous sections actually reminded me. I mean, everyone's played Tetris before, right? You ever notice that every block is 4? Yeah. I didn't pay attention to that myself, all right? But so you think of Tetris with 4 blocks. Okay? Penta, okay? I used to tell all my classes just think of, I don't know. See, everyone says pentagon first. There's something wrong with me because I think of like, you know, pentagrams and like devil worshippers. All right? But whatever it is that you need to memorize that, all right? 5 is penta. All right? Hexagons, those are relatively common. Hepta, I have no idea. All right? Octa, think of octopus, or someone from another section said octomom. I don't know if you watch a lot of news. All right, nana, I don't know. And deca, I don't know either. Okay. Decade, there you go. Look at that. You guys are way better at this than I am. Okay. Yeah. Well, we're going to spend really the rest of the class period doing examples with this. Okay. So if we have 2 or more nonmetals, we have to say how many we have. Okay. So let's try. Hydrogen's weird, and I won't give you that on the test, okay? Because sometimes hydrogen acts like a metal, sometimes like a nonmetal. Okay, it's just weird like that. Okay, and this is also why, okay, why don't we use hydrogen for blimps anymore? Extremely, extremely flammable. Okay, because hydrogen just has that one electron there. All right. Well, yeah. There's all sorts of uses for hydrogen, but at the same time, it's special. All right. But if we talk about something simpler, let's say we have N5 Cl7. So nitrogen and chlorine. What would I call that? Penta. There we go. All right. So penta, because we have 5 nitrogen. Okay. Hepta, since we have 7. And then we still have to keep that IDE at the end. Okay. Well, chlorine by itself is just chlorine, all right? But if we have a chloride, that means something is bonded with the chlorine. All right. Why don't you guys try these real quick? C8F10 B2O2. Yes. See if you can write those down. See if you can write down the names of these guys. Fluorine. Yes. So the last one, whether we're talking about metal and nonmetal or 2 or more nonmetals, it's that last one's always going to have that IDE. Yeah. Okay, let's try this. N3O6, what's that? Trinitrogen hexaoxide. Okay, what about C8F10? Octacarbon decafluoride. Okay, B2O diboron monoxide. Okay, then finally Li2S. There we go. I was trying to be tricky there. All right, because with 2 or more nonmetals, we have to say how many we have. But if we just have a metal with a nonmetal, we don't. Okay, so it's just lithium sulfide. Okay, good. No, because really, we are basically taking a whole year of chemistry down to 4 weeks. Okay, so we're not going to go into much more detail. Which one?
Why is it lithium sulfide?
Because it's just a metal with a nonmetal.
Okay.
Okay, so 2 or more nonmetals, you have to say how many you have, but a metal and nonmetal, we don't care how many.
Just the ID.
Just that IDE at the end. That's the only thing we have to do. Okay. Now, the only other kind of tricky thing about naming that we're going to go into okay, is when I talk about, well, what are we exhaling right now? Yeah, carbon dioxide. Okay, so just carbon dioxide. But we don't say monocarbon dioxide, all right? Because if we just have one of our first atom, we leave that off, okay? So CO2 is just carbon dioxide, okay? What would I call CO then? Carbon monoxide, okay? See, the more we learn about chemistry, the hopefully more I get you randomly afraid of things, all right?
Carbon trioxide.
That doesn't really exist, but it'd just be CO3.
Just asking if that was ever in.
Not really, as we'll see why these bonds form, but if you did have CO3, that'd just be carbon trioxide.
I just want to know if that was ever in anything that we.
No.
Might be able to make that like
Just wondering.
Yeah.
They're a little too close to the calculation.
So if we look here, all right, I mean, carbon dioxide and carbon monoxide, the only one atom difference, okay? Now, what I could also ask you on a quiz or test is say, well, let's do the reverse of this, okay? When I look at these, all right, N3O6, C8F10, these are our chemical formulas, okay? So I could give you the chemical formula and ask you to tell me what the name is, but I could also just say, well, what would the chemical formula be for tricarbon diiodide? That might not be how you spell diiodide. Yeah. Okay. Means that we have 3 carbons and 2 iodines. Okay. Or I could say, what's the formula for pentaboron trichloride?
5B.
Yeah, so we put the B at the end, so it's B5 as a subscript, okay, Cl3. That's an H. That's not supposed to be an H. Okay. So far, so good? All right, let's do one more exercise then and see if we can try to make this as difficult as possible. All right, I want each of you to come up with the most difficult chemical formula or chemical name you can come up with.
Right now?
Yeah, right now.
Oh man, I thought I was about to Google it.
Come on, it's like 5 till we have 20 minutes. All right?
Can we Google it?
No, we can't Google it. All right? Because remember, only using the rules we've done so far. So it can either be a metal and non-metal or 2 or more non-metal. Now, we could get complex. I can tell you right now, the molecule I spent most of my time with working on in grad school was ethyl hexyl oxyl polythiophene 2,6 nonsense. All right? Things can get way more complex than this. All right? But at the same time, we should be able to figure out the name or the formula of anything with just 2 different types of atoms. Okay? So give that a try. Take a minute. Either give me the name and we'll come up with the formula, or come up with a formula and then we'll figure out what the name is.
If I bring something in here and get you to look at it, you think you can try and pronounce some of these chemical compounds?
Well, sure, we can always give it a try.
Okay.
But we could even do that with anything, any type of food you have in here. I mean, there's some crazy stuff in there.
Patents for something, and I was reading through it, and I was trying to figure out how you pronounce these things, and they're words like this long.
Yeah.
Somewhere 11 font.
Well, and that's a nice thing about this, though, is that using these techniques, we can name anything. Because like I said, there's what, 103 atoms on the periodic table right now. Theoretically, we can combine any of those together to form any chemical compound. All right. You can combine all 103, all right?
Can make something.
Yeah.
Don't know what that is.
No, no.
I don't want to try it.
No, that'd be kind of difficult, especially using these guys down here that only exist for a couple milliseconds. So,
That's why they're down there? Wait, why is uranium down there?
well, uranium's the same way, all right?
It only exists for a couple milliseconds?
No. Only these guys. So, like all these with the little parentheses were artificially created, okay, and like big particle accelerators or something like that, okay. So these don't exist naturally, all right. And so they're so radioactive that they're gone in a couple milliseconds. All right. Here, but I tell you what, just to make me write less, once you have your name or your chemical formula, why don't you come write it up on the board, and then we'll try to name it once everyone has one.
We need the formula too?
No, just one or the other. So either come up with a name, and then we'll try to figure out what the formula should be, or come up with a formula, and we'll try to figure out what the name should be. And remember, stick to these representative ones. So 1, 2, 3, 4, 5, 6, 7, 8.
I'll add a whole bunch of it.
No. Just two different types, all right? Yeah. Look here, I'll even start up here for us. All right, someone has to be brave and put one up here.
So you just basically want
Yeah.
something like that up there?
Yeah, that's it. Appreciate it, Derek. What? Well, yeah, I mean, but that's the point. I want us all to get all of these. Good. All right, thanks. Yes.
Well, I said, I was gonna make it big. Can you write mine down? I have real bad handwriting.
Well, it can't be worse than mine. Sure, what's yours? K5BR3. No, you're fine. I don't know where CI is. Why don't we just change this to C? There we go. Make it a little bit easier there. All right. So say I got all day here. That's fine.
Okay.
As we go forward, we're going to, remember, anything is possible, but some things are more likely than others. So as we go forward with these next chapters, we'll see why, all right, 2 lithiums are going to bond with 1 oxygen, all right? But for right now, we're just going to figure out what the name would be in any situation. How about someone give us a name so we can figure out the...
I don't have a school having stuff on there.
Well, now that's a problem, yeah. All right, there's only 4 of us. Too much work making it get out of chairs. Yeah, I know. All right, good name. And see, what we're probably going to get to in the next class is that when you do have these different groups, we can start coming up with names for them. All right. All right, I think there's, that's fine. And you got 3 of you left. Here's this. Anyone not get back their quiz yet? Derek Keller, right? Finally getting all the Derek straight. Thanks. All right. See for a little bit more room to write all these. Okay. Let's start with mine. Al2S3. So aluminum and sulfur. Aluminum sulfide, because I have a metal and a nonmetal. So aluminium sulfide. Oh, that's definitely not how you spell sulfide. All right. Si8C6. Yeah, that silicon's right to the right there. So yeah, we have octa silicon hexa carbide. Okay, and I'm getting sick of writing these, so we'll just say these last ones. All right. K5Br3. Bromide. Bromine, yeah. So potassium bromide. Because remember, we have a metal and non-metal, so it's just potassium bromide. Okay. Mg3N4. Well, just magnesium nitride. Okay. Oh, yeah, yeah. So, yeah, we're.
You don't have to put the oxide or.
Yeah. Well, ooh. Well, so this is a non-metal and a non-metal. So what do we call this? This one's kind of tricky. Yeah. If it just has one, we just leave out that mono. So it's just silicon trizenide. Zenide. Okay. And then, yeah, potassium chloride would just be KCl. I should have said no hydrogens. We'll pretend that hydrogen here is a metal. So hydrogen H4O8. Yeah. It just be hydrogen oxide, really. Yeah. Don't worry about that. Hydrogen just makes things more complex. Okay. Well, that's true, but not beyond the scope of our class. Okay, O8Ne7. Octaoxide heptaneide. Yeah. And then Li4 lithium iodide. Okay. And now there's a reason some of these sound so weird, like octa-oxygen heptaneide. As we'll see later, neon doesn't really form bonds. Okay. So it's not very likely to happen. Okay. So what you should be able to do for now, this is all for this chapter. All right. In addition to these, which are just reading the periodic table, all right, look at these other last few that are just more naming practice. Okay. Remember, metal and non-metal, we don't have to say how many we have. 2 or more non-metals, we do. Okay. All right. I'll see you guys next week. Oh, and look for an email because I might have to cancel class on Monday or Wednesday, and if what I do is I'll just put a lecture online and give you a quiz online to. We'll fix that.
Never knew how to get into it. I didn't even know I had one of those.
Yeah, you gotta use name, then your first name, something else.
Protons and electrons be that number right here in the corner.
Oh, I see. What I was asking for here? I have a pen somewhere. Okay, so what I was asking for here was you to tell me like where at, give me a model of the atom. So when we talk about model of the atom, the protons and neutrons are going to be in the center. Protons are positive, neutrons neutral. Okay, and then orbiting around it are the electrons.
Okay.
Yeah.
That's what it was.
That did confuse me there, but yeah, no, you're right if you look here, yeah. All right.
Something with some examples of some really complicated things. I got a patent for agitated gas generator at my house.
Really, whose patent is it?
I don't remember whose patent it is because it was something me and a guy were talking for. Because we were gonna build we needed to build that so we could build I can't think of the name of it right now. There's a generator that's theoretical. The Swiss are doing it right now.
Well, definitely bring it in, and we can try to read through it, because really with these basic laws, we should be able to reason out every part of that. I mean, the only difficult part, though, is that when you start having like names for things, like, you know, OH is hydroxide, you know, but we can definitely give that a try.
Like I have it on jump drive. It's like 10 or 15 pages, I believe.
Sounds neat.
It is. I started digging into it and it got kind of overwhelming. So.
Well, yeah, those patents can be very complex, especially because they make the wording be so technical, you know, that
to keep
it's,
people from stealing
yeah,
like
yeah.
we're trying to do.
Yeah. It seems like a problem.
We weren't really trying to steal it. We were trying to use it. We were going to replicate it.
Yeah. Huh.
And we were into making the magnets for the generator.
Uh-huh.
Because it was a plasma generator.
Oh.
You use magnetic fields to control the plasma.
See, I know they can do something like that with like microwaves, basically. You know, they can rig up a microwave to do that. But
Well, a much easier way is like if you ever see the big plasma generators that they have over there, it looks like a big donut.
yeah.
The walls of it
Yeah.
are basically lined with gigantic electromagnets because the electromagnets keep the plasma from getting out of hand.
So basically like a small accelerator.
Yes.
Yeah. Yeah. Cool.
Instead of particles, it's plasma.
Yeah.
It's neat.
Got a question about my quiz that I took today.
Sure.
The first two.
Let's see if I can find this. There we go. Yeah, so the numbers are right.
Yeah, the numbers are right, but
Yeah.
I don't know.
I'll probably just take off a point for each of those. But remember, it's the atomic number here that tells you what you have. Okay? Not this mass number up
I
top.
thought you always. What's this number up top?
The mass number.
Okay, so we go by the bottom.
Yeah, because remember, the atomic number doesn't change for a given atom. Okay? So uranium is always going to have an atomic number of 92. Okay? But its mass number can change because it can have a different number of neutrons.
Right. I always get these numbers confused because on here it has.
They're flipped around, yeah.
Exactly.
But remember that the easiest way for me to remember is that atomic number is just protons. Okay, mass number is protons plus neutrons. Right. So the mass number is always going to be bigger than the atomic number.
Right.
So.
The atomic mass, right?
Well, that's the mass number. The atomic mass on the periodic table tells you the average of every isotope.
That exists.
Yes.
Right.
Yeah.
Right.
And that's why we have some in parentheses, because there's only one known isotope.
All right. That's all I wanted to know.
All right.
All right. Have a good weekend.
Yeah, you too. Hi.
Hi.
What can I do for you?
Can you see the website dhmo.org?
No, I don't know what that is.
About the dangers of dihydrogen monoxide.
Oh. Yeah, there was something in Congress about that not too long ago. They were trying to say, like, be afraid of dihydrogen monoxide, and then they realized that's water. Like, water's in all this stuff that kills us, but it's kind of necessary. Yeah.
Are you Dr.
Yeah.
I'm trying to remember who that was.
Yeah, nope, that's me. And I'm here with physical science and physics all the time.
I'm in Miss Schaefer's class.
Yeah. No, I'm around. Yeah, if you ever take a physical science class, it'll probably be me.
I mean, I might eventually, and probably have to sometime.
Yeah, it seems like everyone has to get to it eventually. Yeah. I know, there's some weird stuff out there.
But I'm the person who thinks that neutrinos sounds like a cereal.
Well, it does a little bit. They have all these weird names for things, so they kind of do sound like odd things over time.